Okay, this is section 1.1, the study of chemistry. So this is the introductory section to the textbook, really. And so you're going to be studying all sorts of aspects of chemistry in this course. There's a lot of terminology that you'll have to get used to or become familiar with. And let's point out that the study of chemistry is really the study of matter, which is all the material that we interact with in the universe, and energy. We'll talk more about energy as the course goes on, and the changes in those two quantities, changes in matter and changes in energy. That's really what the study of chemistry is. So matter is anything that takes up space. Right, so gas in a balloon would be matter, a rock would be matter, things like that. Energy is the capacity, the ability to do what we call work. And we'll talk more about that when we get into chapter 5, our discussion of thermochemistry. Okay? What we do know is that from a chemical perspective, the smallest unit is called the atom, atom. And it is often useful to represent these atoms as little balls, little spheres. They're three-dimensional spheres. Maybe we would shade them in. Maybe we would indicate something like that. Those are called atoms. It turns out there are different types of atoms. There's around 118 types of atoms in the universe that we know of, and those are called elements. And you're familiar with some of these elements. You're familiar, for example, of hydrogen. You may not know many details about hydrogen, but you're at least familiar with it. Oxygen, gold, iron. And you may very well realize that there are symbols that we use to represent these elements. Okay? So we'll talk more about atoms when we get into chapter 2. You may also be familiar with the idea of compounds. And compounds are combinations of elements in a fixed ratio. So for example, there's a substance that has 2 iron atoms for every 3 oxygen atoms. Now this has a technical name, but we often refer to it as rust. There's another compound that has 2 hydrogen atoms for every 1 oxygen atom. And we're familiar with that one. We call it water. So those are compounds. Okay. Now often one of the difficulties in chemistry is that we talk about observations that we make in what we call the macroscopic region. Let me make this picture a little bit bigger. So for example, if you look at these images here, these are examples of chemical reactions, some of which are happening very slowly, some of which are happening pretty quickly. The first one on the top left is the burning of natural gas. That's a chemical reaction. The second one to the right, which is C in this list, is the rusting of a piece of iron. It's actually turning into Fe2O3. On the right, in figure E, they're doing some forensic work. They've added some sort of compound that reacts with fingerprints, and then they're illuminating it with ultraviolet radiation to see if there was any reaction, which would indicate that there's a fingerprint there. That's a chemical reaction taking place between the material and the fingerprint and the spray that they're putting on. Alka-Seltzer, right? Down at the bottom, Alka-Seltzer is a reaction. So often chemical reactions are quite visible. We see them happening. The rusting is a very slow process. It would take months to notice this happening. And then down at the bottom, the baking of cookies, that is certainly a chemical combination of chemical reactions that are taking place. Okay. Now, when we look at discussing or describing these atoms, as I said, it's not unusual to use little balls to represent them, and there is often a color code to that. So hydrogen atoms are often represented with little white balls, carbon atoms with little black ones, oxygens red ones, fluorine sort of greenish, chlorine also green, so forth and so on. So as you look at the figures in the textbook, you'll see these color codes. Here's an example, two examples actually, two ways of representing a molecule. This is H2O or water. The oxygen is at the center, surrounded by two hydrogen atoms in a V shape. So the oxygen is red, the hydrogens are white. The top one is called a ball and stick figure because the atoms are connected by sticks. And then at the bottom, that's actually a little more realistic to what they actually look like, a water molecule. These are called space-filling models. So we won't see a lot of space-filling models in this course because they're a little bit cumbersome to work with. But the ball and stick figures, those are a pretty common way of representing things. Okay? So molecular substances. Now, what I want to do is I want to show you, if I can find the figure here. Oops, I'm sorry. Let me figure this, where these arts are. There we go. I knew it was here somewhere. Okay, so down here, what we have is a flow chart of what's called the scientific process. Or the scientific method. Every science textbook's got to show you something, have some discussion of the scientific method. So I'll just go through it really briefly. The first step is that you observe something, some sort of natural phenomenon. Now, the example that's used in here is an interesting one for these times. It has to do with smallpox, which is a deadly disease which has been eliminated on the earth over the last 100 years. There was a man in England who came up with the interesting observation that there were not victims of smallpox for women who were milkmaids. So these were women that were interacting with cows and getting milk. They were not contracting smallpox. So that was an observation that there might be some relationship, or the observation is that the milkmaids didn't contract smallpox. So he came up with a hypothesis. So his hypothesis, which is just an initial explanation for maybe why something is being observed. So you start with observation and you get to what's called a hypothesis. His hypothesis is just an idea, is that maybe what happens is the milkmaids are contracting a related disease to smallpox called cowpox, and that cowpox virus, once they contract it, their body develops some sort of immunity to smallpox. So he tried an experiment. So you develop, this is something you invent, some sort of experiment to test the hypothesis. So what he did was he took a healthy child and exposed the healthy child to cowpox, letting the child get sick, and then exposed the child to smallpox. Now, obviously, you couldn't do that kind of thing very easily today. But what he found was that the data suggested that was pretty true, that was probably what was happening, or at least that the child was not getting smallpox, okay? So it supports the hypothesis, supports this idea. If it had not supported the hypothesis, let's say he had been exposed to the cowpox, but then still got smallpox, then he would have to change that hypothesis, come up with a different hypothesis to explain what he's observing, okay? So what happened was, because the child didn't contract smallpox, it seems as though the immunity was resulted from the cowpox exposure. Now, if you run different types of experiments, try different children, try children from different areas, different ages, that sort of thing, and you keep getting the same result, essentially, that if they're exposed to the cowpox, they don't contract smallpox, then eventually you can develop what we would call a theory, which is a real explanation for what is happening. And so eventually, upon further testing, this hypothesis could become a theory of what's happening. Okay, so that's the scientific method.